Hello, and welcome to Code Next Door. My name is Andre, and today we will be going over Erlang term storage. Erlang term storage is an in-memory storage that stores tuples of data as rows. They're created and owned by individual processes, and they're fast and lightweight. There are different types of tables that you can create with Erlang term storage, also known as ETS tables. The first and the default is a set. In a set, there's only one value per key, and the keys are unique. There's an ordered set in which they're ordered by term, and the keys do not need to match as long as they're compared equally. And in an ordered set, 2 and 2.0 are also equal. You can create a bag in which a key can have many tuples, but each tuple has to be unique. Or you can create a duplicate bag, which is the same thing as a bag, but in this case, duplicates are allowed. There are access controls that you can give to ETS tables, and by that, I mean giving ownership to who can do what. So public is where you're able to read and write, and any process can do that. You can also have it be protected, which is the default, and in this case, all processes are able to read, but only the owner is able to write. And then private, and in this case, only the owner has the ability to read or write to this table. How does one go about creating an ETS table? Well, you want to use the Erlang module ETS and the function new. The first argument we're going to give it is the people as an atom, which is the table name, and then the second argument is the list of properties this table will have. So in this case, we give it a table type of set, which means only one key and one value per key. Next, we give it the access control public, which means any process is able to read and write to this table. And then this new one, name table, allows us to access this table via its name. So if we run this, we get back people. And you can see above, if you don't do that and give it a name table, you'll be having a reference instead. But since we use name table, we get back the atom people. So how does one go about inserting data? So now that we have a table created, we give it use the Erlang module ETS again, and this function insert, where now that we have a name table, we can access it via its name, people, as an atom. So we pass that as the first argument, and then we give it a tuple, which is going to be the row of data. And then the first element is the key. So in this case, the string Andre. And then the second element is a integer 27, and the third element is another string NJ. So if we now run this, we get back true, letting us know that the data has been inserted into the table. But if you want to do a bunch of inserts at once, rather than doing it one by one, you can pass in a list of tuples. So same as above, we're using the function insert in the Erlang module, pass in the first argument of the atom people, which is the table name, and then we have a list of tuples that we want to insert into the table, and if we run that, we get back true, letting us know that that data has been inserted. But since this table is a set, the data will overwrite if we run insert again on the same key. And to avoid that, we can use insert new. And in a set, an ordered set, we can have insert new run, and if a duplicate is found, it won't insert it and it won't overwrite. So if we run this, we look up by the key Andre in the table people, and we get back that the same data we had above, Andre 25, 27, and New Jersey. And for reference, if we take this out and just run insert, and we run this again, now we have that Andre has been overwritten with new data. So now, how does one go about fetching data? Well, in order to fetch data, we are creating a new table, animals, and now it's an ordered set, which means it's ordered by the term. And public control and a name table, so we can exit via its name. And if we want to insert a bunch of data, we can have animals to the table, a bunch of animals have been inserted, and we use lookup. In this, we are looking up on the animals table, and we're looking for a key horse. And if we look that up, we get back horse. Now you can also look up by element. So in this case, we look up on the animals table for horse, and we look at the first element. And in this case, we get horse. And now we can also see if something is a member. So we're going to look to see if chicken is inside the animals table. And if we run this, we get back true, letting us know that chicken is indeed part of the animals table. And if we look at, say, fox, and try to run that, we get back false, because fox is not in the table. Since we have an ordered set and things are now ordered by term, we can also use what is known as first, letting us know what is the first entry into the table. In this case, cat, because cat, if we go and see what was inserted, we had horse, dog, cat, chicken, cow, and eagle. And if we order them, cat, it will be the first thing. And then now if we look up last, we can assume that horse will be the last thing. So now, how about all important deleting data? So in order to delete data, we want to use just delete. So in this case, we insert a bunch of things into the table people, and let's say that we want to delete Chris. Well, if we delete and do a lookup, we will see that Chris is no longer in the table. And in order to delete, you just pass in the table name, people, and then the key that you want to delete. Now, if we want to delete all the objects, you can do that by just using the function delete all objects in the Erlang module for ETS module. And delete all objects, you pass in the table name, and you can now delete. And you'll see this is a new one. We get end of table because it cannot find that. So first, we'll not have anything there. So we get this error. Another thing you can do with the Erlang module ETS is delete an object. So in this case, we want to delete the whole object Lucy, but we want to match on specific data. So here we want to call the function delete object, pass in the name table people, and then we want to look for the tuple Lucy with the string or the integer 22 and the string il, and we want to delete that specific object. So this is useful if you are in something like a bag or duplicate bag where there are multiple keys can be duplicates. So in this case, we want to delete Lucy, and if we run this, we get back empty list, letting us know that Lucy has been deleted. and it can't be looked up anymore. So now, what about deleting a whole table? Well, it's as simple as running the function delete from the Erlang module ETS and passing in the table people. And if you now run this, we get back true, letting us know that the table people has been deleted. Thank you for watching. Hope you enjoy the content. If you want to learn more about ETS and want some more videos, leave a comment. And thank you.